Hi, my name is Elizabeth Sanchez, and I will be presenting my proposed research topic on gut microbiota composition during the perinatal period and prenatal period affects allergic responses in mouse model. Asthma is a chronic respiratory disease that affects millions of people worldwide. It is a condition that causes inflammation and narrowing of the airways, making it difficult to breathe. There are various symptoms, including wheezing, coughing, chest tightness, and shortness of breath. It is considered a serious health condition because it can be life-threatening in some cases. When asthma symptoms are severe, they can lead to an asthma attack, which causes the airways to become even more inflamed and narrow. In many cases, asthma attacks can be fatal and lead to possible death. Vancomycin is an antibiotic that is used to treat serious infections. Its purpose is to help prevent the growth and spread of bacteria. It is commonly used in humans, children, and animals. It is usually given when other antibiotics are not strong enough for the infection or disease. The gut microbiota is essential in mice for several reasons. First, it helps to regulate the immune system, which is essential for fighting off infections and diseases. Second, it helps digest food and extract nutrients that help maintain a healthy body weight. Third, it plays a role in behavior and brain function. Finally, the microbiota can have influence how mice respond to drugs and other therapeutic inventions. The alteration of the gut microbiota has been proven from age and diet, but the prescription of specific antibiotics are still unclear. Studies have found that the alteration of the gut microbiota can have a range of effects on their behavior, weight gain, and immune function. Oftentimes, antibiotics can be prescribed before birth if the mother has an infection. Also, antibiotics can be given shortly after birth as the baby has a weakened immune system and can develop infections. This can cause a disturbance in the child in the womb and even after birth. Therefore, the goal of the study is to determine the effects of vancomycin given prenatally and perinatally to discover which group will have more mice that developed asthma. The hypothesis for this study is mice that receive vancomycin prenatally will alter their microbiota and develop asthma. The study plans to use Mus musculus mice because they are the most common research animals and are useful model organisms for understanding and studying human disease. They also have similar gut microbiota compared to humans. For this experiment, there will be 3 groups of mice, 25 in each group. The first group of mice will be treated prenatally with vancomycin. 25 pregnant ill mice will be injected daily with 1.5 grams of vancomycin for 6 weeks. For the second group, 25 ill mice will be given vancomycin prenatally until the mice give birth to their newborns, in which they will be given 0.2 grams of vancomycin for 6 weeks, and the dosage will increase by 0.1 gram at the end of the week as their weight increases. The third group of mice will be labeled as a control group as they will not be receiving any antibiotic treatment. The mice will be injected with vancomycin in their left thigh. For the sample collection, each group's fecal sample will collect 0.05 grams for analysis. The study will analyze the microbiota using 16S RNA sequencing, which is where the DNA from the fecal sample is extracted and the 16S RNA gene is amplified using PCR. This technique can provide a detailed picture of the microbial community in a sample and is commonly used in microbiome research. For the asthma development monitoring, there will be comparison of the gut microbiota with mice that have asthma and mice that do not have asthma to determine the differences that could be associated with the disease. Also, we could look for metabolites that are produced by the gut microbiota as they play a role in the development of asthma. For example, FCFA, which is short-chain fatty acids, can have anti-inflammatory effects and may help regulate the immune system. If there are lower levels of short-chain fatty acids in the gut, this can also be a factor in the increased risk of asthma. By analyzing the complex interactions between the gut microbiota and the immune system, researchers hope to get a better understanding of the disease. For the expected results, we will compare the amount of mice that developed asthma to the control group. The first group of mice which received vancomycin prenatally will have more mice that developed asthma. The second group, which was the perinatal treatment of vancomycin, will have fewer mice that developed asthma than the first group. From the following results, this adds to other research by demonstrating that prenatal exposure to vancomycin is associated with an increased risk of asthma. Even though antibiotics are beneficial for diseases and infections at a young age, it can have negative effects such as an alteration of the gut microbiota. Specifically, the alteration of the gut microbiota in mice has an increased risk of asthma. The results supported my hypothesis, which was mice that receive vancomycin prenatally will alter their microbiota and develop asthma. In this experiment, there could have been a reaction in mice from the vancomycin, which could have caused illness and may have led to possible death. Also, there could have been some errors in the time dosage. Even though the study was done on mice, future research should be conducted to determine whether findings can be applied to humans. I would like to thank my science research instructor, my junior mentor, and my peers. Thank you.